Welcome everybody. My name is Daniel Hinojosa from Albuquerque, New Mexico, and going to talk about property testing in Java, something that I've been using in Scala for a few years. I was thinking about property testing and just wondering, does Java have some libraries for property testing? I think it's very valuable to have property testing. We'll describe what property testing is. And I thought, yeah, is there something in Java? And I just found out, yeah, there are 3 major libraries. So that's what this particular presentation is going to be about. And also just, some of the overall benefits for property testing. So my content and slides are up on here. So if you want to take a picture, all the demos are up on here. Slides, you know what? I think I need to put them on there, but I'll go ahead and put them on there after this particular presentation. So I'll let this stand here for a bit. If you want to take a picture of it, by all means, go ahead. And again, all the material is going to be right up on here. All right? All right. And if you didn't catch that, just see me after the presentation. So overview, let's talk about what is a property. So a property is going to be exhaustive testing through fuzzing. And so the idea of fuzzing is that we're going to unleash chaos in our production. In our production code, we're going to unleash a whole set of inputs, some that we're not really thinking about whenever we do the testing. So fuzzing is hundreds or more, maybe thousands, maybe 2,000s, maybe 10,000 of just random inputs, one or more values that are associated with it. The throttling your functions or methods with a lot of these inputs. Again, this is just pure chaos that we're unleashing onto your functions and onto your methods. That's the idea that's going on here. So we're looking for invalid values. Again, the computer doesn't care. We tend to have our own biases as to what kind of values do we want to put into our functions, which kind of values do we want to put in our methods, because we always like to think about, hey, let's do our happy path. Hey, I'm going to put a 1, I'm going to put a 0 because that's what I'm thinking about right now. And TDD is very much like that. When we do test-driven development, we tend to put the values that we think we want to test for. And our brain kind of has this one-track mind. Now, if we unleash the computer on it, computer's nuts, right? Computer's absolutely nuts. It's like, all right, I'm going to throw a minimum value. I'm going to throw something to this. So invalid values. Let's throw some invalid values at this. Let's just throw some random crap at it too. Okay? Let's just throw some of these values in there and some unexpected values like min value, max value, some of the things that we're not absolutely thinking about. Now, let me ask a question over here. How many of you are active TDDers? You love TDD so much? You have how many of you have a tattoo of TDD on your arm? Anybody? No? All right. So the idea for property testing is that, hey, let's take TDD and let's go super duper power a little bit extra to this. And I think the combination of both of these is absolutely great, to do some TDD and then afterwards just unleash the chaos of property testing on this. And then what you could possibly do then is from your property test, hey, these are a couple of values that sunk my code. Let me take those input values and maybe make a unit test out of it to strengthen the code that I've already developed, okay? And that's really one of the cool things when it comes to property testing. Another thing I like to think about property testing is kind of like these martial arts like Aikido, maybe Jiu-Jitsu, where most of the moves that you have there are purely defensive. A lot of these martial arts are again, purely defensive. They use their own weight against your opponent or whoever's coming at you. Same kind of thing here. We're just having it create some random values, and we're just taking all that information and having it work against itself. So I'll talk to you about an example here very, very soon as to what I mean by using its own weight against it, okay? So how is this different than a unit test, okay? Well, this doesn't have a direct assignment of value like you would with a test-driven development. I'm not going to say, hey, I'm thinking about X should be equal to 1, maybe Y should equal 0. I'm not thinking in that regard when it comes to a property-based testing. With property-based testing, again, everything is random. I don't know what is going to be input into this, and that's going to be the greatest part about all this. So I want to make sure that a certain rule holds for my software, okay? So we'll talk about some of these patterns in here and using our own weight against our code to come up with this. So these rules are called properties. I should have some kind of property. I should see some kind of property. In fact, you're going to go into investigative mode, or you're probably going to go into philosopher mode when it comes to property testing. Probably make some tea. If you have facial hair, stroke it like this. So you're going to go, there we go, that's a nice beard. So you're going to go really into deep thought mode as to, hey, what makes a good property? Now, the anti-pattern to all this is that you could end up defining a property when, and what happens is that you end up defining the exact same copy of the production code in your property test. So that's something that you want to avoid always, okay? That's an anti-pattern. So let's think about some properties, and I'm going to just throw some questions at you. Or how about I do the first one here? How about reversing a string? So if I want to reverse a string, foo, let's say capital F, small o, and I flip it to OO and then capital F, what are some properties that I see there? Again, I don't want to re-implement my production code in my test, but there's something to it, right? There's something to this reverse string, a rule that I could come up with, an axiom that you could come up with to say, you know what? Given these rules, these should always hold. And that's where property testing comes in. So let me do the first one in here. Tell me what you think. If I reverse a string, the beginning of the original string, or the first character of the original string, should be the end of the reverse. Do you see that as a rule? Like, I'm not trying to reinvent the production code or the thing that I am developing for, but that rule holds, right? If I reverse a string, the first one on the original should equal to the last one on the one that has been changed. Always, right? And you feel it. You feel it in your gut. You're like, oh yeah, that's very true. That first one should always equal to the last one. So why not make a rule of it? Why not make it a property? And then, the more and more I do this, that rule should always hold. Let's see, how about another one? The end of the original string is the beginning of the reverse, so we could go the other way around. Maybe the middle is the same. If I reverse, let's see, if I have like 5 letters and I reverse it, ow, that hurt. If I reverse it, I'm not going to show you my middle finger, but if I reverse it, this should always stay the same. Like if I reverse it, that should hold, right? That's a nice property, and that should always hold every time I run it. If you reverse, this one's good. So this is the one I was talking about, very much like jujitsu, where we're using its own force against it. Do you see how this works? If I reverse the reverse string, I should get the original string, right? How cool is that? Like, that's almost very much like a cool martial art on here. Oh yeah? Well, let's take the reverse of the reverse and see if that's the original. Wow, yeah. Awesome. So that is a nice little property in there. So this is what I mean that, get fanciful, get creative with this, and then you could establish some of these properties. Again, worth reiterating, what we don't want to do, so we don't want to redesign the production code in the test. That's always a possibility. If you find yourself going down that path, stop, reevaluate, and rethink. All right. No, my mic's not on. So you wouldn't tell because my voice is loud. All right. Here, you want which one?
Oh, you have all 3 on.
I have 3 on, yeah.
Okay, so we're going to just use... I'm sorry to interrupt you.
No problem.
Which one is it?
I feel like I'm in TSA.
Go ahead.
All right. Hey, whoa, hello. Okay, now I'm really loud. Can that be turned down?
You want me to turn it down?
Yeah, because I'm really loud.
Okay, go ahead.
All right, sounds good. Test 1, 2, test 1, 2, test 1, 2, test 1, 2. Thanks. All right, so let's go for this one. What do you think on this one? Concatenating 2 lists. What property would you think? Again, you don't want to reinvent it on the test side. What are some properties that you would think? Go.
Lengths would add up to the concatenated length would be the sum of.
Yep, cool. Anybody have another one? Yeah.
Any element of the original list should be on the resulting list.
Ooh, that's a good one. Yeah, I didn't think about that one. I like that one a lot. Yep. So see how awesome that is? So if you think about these particular patterns, here are some of the concatenating result of the 2 lists must be greater than or equal to. So that equal to sometimes will sting you. And so we'll think about that. Again, my brain's not thinking about like empty strings all the time. But if I'm concatenating two empty lists, maybe not a string, but if I'm concatenating two empty lists, that should be equal. Because if I'm concatenating two empty lists, that's still 0, or the size of that is still 0. That could pinch you. So the sum of the size of the two lists should be equal to the concatenation, or at least you should find that element within that concatenated list. That should always hold. That should be a property that you always see. Let me throw a little nice little curveball at you here. What about building a custom map? So we have already Java util hash map, and it works great, but you have a different implementation because you need this for something. You need this for your work, and you need to build a custom map. What's a property there that you can come up with? That was a tough one. So one of them happens to be this. How about we compare it against something that has already been developed? Like there are certain rules when it comes to a hash map, right? I shouldn't have duplicate keys in the hash map. I don't know, there's probably a certain time on how long something takes. Maybe that's not something very much of a property test. But there are certain rules when it comes to a map that always hold true. And so why don't we just compare this to something that has already been developed, okay? That's a property itself. And again, using its own weight against it. Let's do an easy one here. Someone tell me a property of absolute value of a number. Always positive, all right? Always be positive when it comes to an absolute value. So there's a nice little simple rule here. It should always be greater than or equal to 0. Now that I'm presenting right now, sometimes things pop up in my brain. Equal to 0. Can you take the absolute value of a 0? I think so. So I think that should be a 0. Yep. All right. Some of you don't know what FizzBuzz is. I think FizzBuzz is a lot of companies' favorite entry exams. It's very interesting. This one comes from a blog post. This one says, the FizzBuzz test is an interview question designed to help filter out 99.5% of programming job candidates who can't seem to program their way out of a wet paper bag, which is terrible. This is just like a terrible way of describing people. I don't believe 99.9 or 99.5%. I think that's not a very true number. I did ask this for a major company and who does hiring, and they said, yeah, we use FizzBuzz. It's somewhere around 60%. So people still fail this test, and it's kind of an outstanding test, and here it is. Write a program that prints the numbers from 1 to 100. For multiples of 3, print fizz. For multiples of 5, print buzz. And for both multiples of 3 and 5, print FizzBuzz. And this one sinks a lot of people, and one of the reasons is you end up chasing your tail. So let me ask you this. So at university, when you had your programming assignment due on Monday, when did you start it? Be honest. Sunday night, right? 9 p.m. Like, holy crap, I have some, I have a software lab to do. So, yeah, you would start Sunday night, and what happened? So I'm just speaking from my experience. What I did was, I looked at what the professor wanted me to do, and I did the first thing, and it worked. I was like, yeah, great. And then I did the second thing, and what happened? I broke the first. But I didn't have any remnant around because I was just using that main method to put that information in there. And so I erased essentially my test that was inside of my main method. And then I just compounded and compounded until I got to the 5th element of the programming assignment, and everything else was broken. And all of a sudden, starting at 9 p.m. on Sunday, all of a sudden what? It's like 3 a.m., 4 a.m. Monday, and I need to turn this in at 9 a.m. On Monday. So TDE really keeps your mind focused, but property testing is really good for FizzBuzz as well. So here are the rules again. 1 to 100, 3 is a fizz, 5 is a buzz. Multiples of both 3 and 5 are FizzBuzz. So question to you then, what's a nice property for FizzBuzz then? How about I give the test a whole slew of numbers, and maybe they're all like 3, 6, 9, 12. And if I just run this as a set of inputs, that should always print, or the string should always start with fizz. Now, that's kind of clever, right? And how about 5? That should end with buzz. But that should also capture fizzbuzz, because it should print out fizzbuzz if it has a 3 and 5. And those are properties that we could set on there. So it takes some cleverness, okay, to do these kind of property-based tests. And you could apply these for just about everything. But again, the key part to all this is for you to be clever. What a property test will not give you, it's not a replacement for test-driven development. There are some whose opinions are test-driven development is not necessarily needed once you have property tests, and I personally disagree with it. I like test-driven development because I am focused on one particular aspect of what I am trying to design for. Like, hey, I got these 2 very discrete inputs and I want to plug them into my method. Like, I am focused on that. But property-based testing is just this pure chaos thing. Yeah, I'm just going to throw in a bunch of values in here, and it's going to find, some problems with my code. So it's not a randomizer of input. It has a specific need to find the outliers and to plug those outliers in to do harm to your code. Okay? That way, no one else does harm to your code. So let's speak of values. So as of values, 0, 1, integer max value, integer min value are all different things that will be plugged in as part of this property test. So some history behind the scenes here. Things started out with quick check in Haskell. That's where all this started. So when you see the word check, we're looking at kind of like a property-based test when we talk about checking. So it started with Haskell. I left some links over here. Then Scala Check, and this is where I first learned about property-based testing. So here's a property-based test for Scala. This one uses something called an object and extends properties where that text in there is essentially, hey, this is what my test is, just a description for it. And then I have this property, and the for all here, and you're going to see this for all when I talk about Java. So there is a for all which says, hey, give me a boatload of list events and plug them in here. And what I'd like to do is this. Hey, here's a wonderful property. Like I said, if I do a reverse of a list, and if I do the reverse of a list, then I should get that same list. And there's my assertion. Booyah, okay? So that's where things started. Now, let me tell you about my personal failure as well. I do teach test-driven development. I love test-driven development. I like talking about it. And one of my first examples that I always talk about is Caesar shift. Anybody know what Caesar shift is? Okay, Caesar shift is this. Let's say I start off with the word foo, capital F, small o. And let's say I'm in agreement with somebody, okay? Let's say with you, I'm going to send you a secret message, wink, right? And the secret message, so no one look, it's 5, right? So he and I are having a little discussion in here as to what that number is, 5, okay? So he knows the number, I know the number, the rest of you don't know the number. So if I send a message, KTT, over to you, you know that our secret number is a positive 5. So all you have to do is just reverse those letters on there. I love teaching this with test-driven development because it is pure evil. And the great part about this is that I get rolled eyeballs because everyone thinks it's so wonderfully easy, but then the evil lurks. What do you think the evil is for this kind of thing? Where are things going to get hard?
When it hits Z and you have to
Go around. Yeah, you have to go around, right? Or yeah, you're at Z and then all of a sudden it's +1. What do you do then? I leave it up to them, but usually we want to go circle back around to A. But also capitalization. What to do with numbers, what to do with exclamation marks, and what to do if, it's not that quite simple. Let's say I'm in Z and I go to 26, where should I be? Right? It should circle back around again. I should be right back at Z. But what if I give it something that's divisible by 26? Maybe, I don't know, 10,500,000, and let's say that's divisible by 26. I mean, that's going to circle a few million times. I should still be back at Z. So there's a lot of room for error when it comes to this. So if you're looking for a really good test-driven development example, boom, right there. That is going to be the Caesar shift. So what happened? So I go get done through my class here, and everything is working out great. Here's what Caesar shift ends up looking like, at least for me. What I really like about test-driven development is that the code that you get at the very end is somewhat beautiful, right? Because you refactor along the way, and then it gets a little bit more concise over time. So I tell them, I tell my class, hey, just take a look how beautiful this is, okay? Everything is pretty concise. We ended up using functional programming. Is this one? No, this one I'm using a for loop. But it works out great. And I get done with my class, and let's say right over here, let me do a presentation mode. Let's go here, okay. Okay, there it is. So here's my test, and I have a lot of different tests. We start off with something simple called the anchor called, hey, I want to start with a string and 0, and let's go from here. So we add. These comments here where I show like green bar, that just means that I'm coming up with a test that I know very well is going to pass, but I just want to put it in there anyway. I just say the goal for like my test-driven development is find red bar tests, find things that will challenge your code, because you could come up with like 10 million green bar tests and doesn't necessarily challenge your code. So always challenge your code with something that would possibly break. And so I have these annotations in here. Anyway, class goes by well. I run this particular test. Watch it fail right now. But I run this particular test, and I should get a green bar on this, okay? So got 19 tests. I feel cocky, and I feel like, great, hey, this is what TDD can do for you. It's foolproof. And then what? Well, let me come in over here, and let's say that I'm going to go to this property test. And so here's a property test. And this is the awesomeness of a property test. The property test is now, hey, Chaos, can you check out my code and tell me what you think? And again, what this is going to do is just going to throw anything at it. So what is going on here? Well, Caesar shift takes two inputs. One is an original string, and then the other thing is what I have coming in here is the shift. How much do you want to shift by, right? So if I have foo and 5, that's the shift. But I'm a human being. What do? I always input the happy path for this, right? A very simple English word, and maybe 1, 2, 3, 4, 5, maybe 26, maybe 1,000, maybe 1,500 to give myself a challenge. But I can only challenge myself so far. This, on the other hand, is a property test. And take a look at the property that I came up with. This was perfect. This is that jujitsu that I was telling you about. Oops, let me come in over here. The jujitsu is this. So if I encode a Caesar shift, so let's say I do foo with +5, and it ends up with KTT. How about if I decode it with 5 again? Should I get foo in the first place? Well, yeah, that's using its own weight against it. And so this is a property test for Caesar shift. Now, what happens if I run this? This one's going to blow up. Let's take a look over here. All right, there it is, okay? In all its failing glory. This one I'm using something called jQuick, and what it did is it put some values in here, and here's what the issue was. Take a look where it says right down here, sample and original sample. Those are the inputs. It said, you know what? I could destroy your test by merely putting in A and -214,748. We should probably all know this by memory. 36 and 48. What number is that? It's it's integer min value. I wasn't even thinking about integer min value. But this just threw in a nice little edge case, another nice little outlier to do harm to my code, okay? That's what the property testing is all about, okay? All right, and these are available to us. So that's what happened, okay? If you enjoy humiliation, this is a great tool to bring that, and it's just like, what was I thinking? Damn it. All right, so Java has 3 particular libraries that I found myself. One of them is jQuick, Qwik. The other one is JUnit Quick Check. Again, there's that word quick check, which comes from Haskell, and Vaver or Vaver, depending how you want to call it. Anyone use Vaver or Vaver right now? It's like super duper extra functional programming. on top of Java. So Vavr already has that. So I'll talk about some of the different ways that you could do it. So some dependencies, jQuick, pretty easy. Just bring in jQuick, but make sure you have Jupyter. So how many of you have moved on to JUnit 5 now? Okay, that's a good number now. So, and the rest of you, JUnit 4. Anybody test NG? Okay, wow, hey, that's a good representation. All right, so for this one, the caveat here is that you would need JUnit 5 in order to use this with jQuick. But jQuick has a lot of functional programming goodness along with it. Always bring in your own insertion library for jQuick and for JUnit Quick Check as well. How many of you use AssertJ for your insertion library? Okay. If you haven't, I love AssertJ. So take a look at that one. That's my recommendation. How many of you use Hamcrest? Okay, 1, 2. Okay. I don't use Hamcrest because it's not kosher. Okay, all right, there we go. Nice. Anyway, but whichever one is your popular one, by all means do it. So easy for Gradle and Maven. For Quick Check, you have 3 different libraries. Usually you have to bring in core and generators to create your own generators. We'll talk about what a generator is. But pretty easy to bring in. Okay. Also bring in your own assertion library as well. And then Vavr, you just need to bring in the Vavr library and your own assertion. But you know what? I should probably make a correction on that slide. You don't actually need that, and I'll show you. Okay. So let's go through all 3. I'm going to go through each of these to tell you how to create a property and how to create your own generators and a few extra bells and whistles. Yeah?
Sorry to interrupt, but with Vavr, you don't need JUnit 5, do you?
No. You need some JUnit. You just need some testing framework. And I'll show you why Vavr is really nice is because it doesn't care what testing framework you want to use. Yep. All right. So creating a property test. I have 3 of these. Let's go through them. So let's take a look over here. I am going to go through here somehow. There we go. Nope, it's not that project. Okay. Good job, demo gods. There we go. I was like, hey, what's going on? All right. There we go. And let's take a look at jQuick right over here. Okay. You kind of saw what jQuick will do. So all you have to do for jQuick, list out at property up at the top of the method, and then you have the for all, which looks very similar to both the Haskell and the Scala Check version in here. So this just says, hey, give me just whatever string you want to give me. Over here is just give me whatever string you want to give me. So if I go ahead and run this, we'll get to see what is meant by a string. Blah, 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 right? Computers don't care. Computers aren't English speakers. Computers are good just with every character in here. And so, we weren't thinking about that, right? And so that's exactly what that will do. All right, let's take a look over here on how to do this in, this is the JUnit Quick Check. It's a little bit different, but you have at property, we have one top annotation on here for your JUnit 4. Here's a little caveat when it comes to JUnit Quick Check. You would need to use, I think you would need to use an older version of JUnit, so we're talking about like a JUnit 4 Classic rather than a JUnit 5. But here it is. No for all in this case. It is able to determine via type, hey, right over here, I would like to provide a string, and then right over here, I'd like to provide a string. Okay, so it already knows how to do that. Let's see, let me come down over here. Let's talk about Vavr. Do it, yeah. What do you got?
I'm just curious, how many different values for these properties would these?
You could specify. So sometimes they call it a try. So you could say, hey, let's throw in 100 values, let's throw in 1,000 values, let's throw in 10,000 values. So you could specify that. Each of them will have their own different numbers. I think Quick Check does a 100. One of them does 100 and does one of them by 1,000 by default, but you could change the numbers as you will. Okay? And it depends on the inputs that you want. So we'll talk about that. Now over here, this is already using a generator. I had no choice there. But take a look right up here. This is an arbitrary, and we'll be taking a look at arbitraries for some other libraries as well. So this arbitrary says, hey, I want a string, but as part of the signature, here's a signature right over here. The signature says, I need something called a gen. Now, this takes a lot from Scala Check in order to do this. But this gen says right over here, I'm going to use this gen in here. This gen says, please choose one of these. Either something from A through Z, small letters, or something from capital A through Z. So I'm crafting my own what is a string in here. And in this case, I'm just going to make it alpha in this case. Now here's a property. One thing I want you to notice here is that I'm not using an annotation. Scala programmers, where a lot of this comes from, we're allergic to annotations. We just don't like annotations all too much, so we don't do that quite a bit. The only annotation that you'll see right up here is the @test, which just signifies that, hey, we're just running a test. But this property says, here's what it is that I'm asserting. For all strings, and what you provide in these for alls here, it's kind of clipped up top, but this says, hey, I want to plug in some arbitraries, which is the kind of data that I want to plug in, which in my case here are the strings, okay? Such that, right in here, as far as this function goes, this such at is a function for my assertions. Given two strings that are just going to be randomly generated, with some outliers, of course, I am asserting that when I concat these strings, that the lengths should be greater than the original strings themselves, okay? Which is going to fail, because, well, let's run it. So if I run this, now you may think, hey, that sounds like a pretty good property, Dan, what's up? It doesn't count for, well, let's see what the answer gives us here. So it gives me all of these in here, and let's see, where is it? Oh, beautiful, right in there. See that? So it went through all these strings, different sizes, different lengths, but the one that it sunk at was this one. Hey, here's a sample, empty string with an actual string. And what was my problem? My problem was I was using greater than instead of greater than or equal to, okay? Awesome. I like Vapor a lot. You may or may not, but they all have different ways of doing things, okay? We could constrain our values as well. You saw the strings, right? They were like all over the place, okay? We had different character sets. But what if I want to constrain it down to like alpha, okay? Or maybe some other language, okay? Maybe Cyrillic, whatever it is that you're looking for. Maybe the numbers I don't want like 1 to integer max value. Maybe I want it within a certain range because I'm just guaranteeing a certain range. I don't have to plug in all these different values. That's what constraining is for. So let's take a look over here. I'm going to take a look at a couple of constraints. Okay. Now, one of the things that may happen is with a constraint, you may starve out your inputs, which could always be like if you get too narrow on the selection set of the inputs that you want to bring in, that could certainly be a problem. But let's take a look over here. This one is, here, let's start with jQuick. Here's jQuick, okay? And here's my constraint. You have a few constraints, so this one just says, hey, I just want to compare string lengths that are only 5, okay? Maybe I have an assertion I already know that this is not a value. I'm not even going to have a value or even allow a value of anything greater than 5. And that's a constraint that I have. You have various constraints. So here's the constraint package. So you can see right over here, alpha characters, just cars, lower cars, so lowercase characters, positive numbers, negative numbers, white space, null, things like that. So you can constrain the kind of input values that are coming in, okay? Or just go pure out full random. So there's that one. Now let me come back over here and let me open, same one, but let me tell you about starvation, okay? Now, let's say I'm testing a prime number. I don't actually have a production code on here, but let's say I'm testing a prime number And let's say my int range here is between 2 and 10. Not a lot of numbers. Now, to your question, someone asked the question like, hey, how many tries does it give it, or how many values does it give it? And I say, depending on the framework, your default could be 100, could be 1,000 are the defaults, but you could have 10,000 or 20,000. Now, if you're expecting 20,000 elements to throttle your method, and you do this kind of constraint in here, you may starve it out. It depends on the testing framework. I think this one will starve. It'll either starve or produce copies. So let me run this one. I forgot what this one will do. So here we go. So this one says for all integers, but a range from 2 through 10, and here we go. We starved it, okay? We're in starvation mode. Starvation, there are only 9 values. And take a look at this generation mode. It says exhaustive. And this is indeed saying, I did what I could, and now I should be giving you 100 values, but you didn't leave me no choice, so I'm only going to give you values from 2 through 10, okay? Your fault. Anyway, it's just something to be aware of, just depending on the test. It can't fulfill that 100. Yep. How did it know what?
How did it know that it was starved? Like, I would imagine it's going to keep calling it over and over again and then realize that it's getting the same numbers back.
I think it just keeps track of the values that I'm sending it. Like, I'm going to send you 10, mark. I'm going to send you 9, mark. I'm going to send you 5, mark. And then the next value is going to be 5, and I'm like, I already gave you that, so I'm going to try to do something else. Yep. Because its job is to try to be as random as possible, but when it realizes it's not being as random or giving you any kind of good inputs, then it's just going to go in starvation mode and stop. Okay? All right. So, constraints in here. Let's take a look at a constraint over in JUnit quick check over here. So, this one I'm using an assumption. A little bit different. Anybody use assume in your tests? Okay. There's always an assert, but there's also an assume. And assume is a precondition. These are the rules that I'm assuming that I should have here. So I could use an assume. They also have annotations as well. So we could use an annotation. Here's an annotation version of the same prime number. And this one is, hey, let's test primality for an in range between 2 through 10. But let's run this one and get to see the results in here. Again, some testing frameworks will have slight differences with one another. Take a look at this one. This one's going to do, it's going to fail, as expected. But let's take a look here. Now, this one doesn't do that mark that I was telling you about. This one is like 10, 9, 4. It doesn't care if you had it before. It's just going to keep going, and I think it's going to keep going for 100 entries. I think this is the one that is 100 entries. So make it a little bit of a different characteristic with each framework, okay? Some will starve, some will just, throw trash at you or duplicates over time, okay? All right. So let's take a look at Vavor over here with the constraint properties. Now, what I like about Vavor is that everything is in your control. You just have to be really good at functional programming, okay? And that's what it is. No annotations. Your job is to construct the elements that are coming in here. And we do this through this arbitrary that is in here. So this says, I want a string composed of small a through z through capitalized A through Z. I want to filter everything where the length is greater than or equal to 5. And then I'm just going to cut out the substring in here. So that's my constraining. In fact, the constraining really is what? The filter in here. Now this is all Java, mind you, but this right in here is the constraining. Afterwards, I'm just manipulating this by making sure that everything is 5 letters. So I'm just constructing my own. No annotation involved, but again, you just have to be good at the functional programming aspect to all this. Now, given this right over here, I have, 5-letter alpha words right over here. And so for all of these, here's the 5 alpha words, 5 alpha words in here, such that blah, blah, blah. Now, I didn't discuss this quite too much. Here's a check, which just means, hey, check these values. Just going to run all these values against it, and I just want to check to make sure that my assertions pass for all the input values that you're providing it. And this one just is, I'm just making an assertion here that everything is satisfied. So we'll talk about this a little bit later, some of the parameters that we have here. You give it your own randomization, but you could also have your own size or number of tries. So if the 100 or if the 1,000 is not your thing, maybe you want to go really aggressive or not aggressive at all, you could plug in your own values. Yeah?
It seems like the filter is unnecessary up there in the generator.
Ooh, nice.
The map is going to bring it down.
The map is going to drive it down. Maybe not. Let's run this afterwards. My thing on this one, I think I did it without the filter before, but what substring will do, if substring is like 3, a length of 3, then it will fail. I think that's why I ended up doing that. Yep. Okay. But if you're interested afterwards, bring out the J shell and we'll give it a try. All right. Okay. So very cool. Great questions, everybody. All right. So that's a constraining. So if I go ahead and run this, I think I have a system out format here. Beautiful. Okay. So all these are 5 letters. Now, I don't think this is going to starve at all. This is just purely, me creating and filtering some information in here, but just because we have so many letters to use in different combinations, 5-letter words are easy to come by, so these things are not going to starve. But if I had like numbers like 2 through 10, there are only a few certain choices that I could actually have with that. Okay? All right. So, okay. Generators. So I want to create my own stuff. You saw a little bit already with that arbitrary. The word arbitrary you're going to see a lot in a lot of these frameworks is, hey, I have some data, but I need something a little bit more, not just regular integers or regular strings or just the dumb stuff like that. I have my own custom code, okay? Maybe I have money, maybe I have customers, maybe I have albums. I have these custom nouns that I want to feed into my tests. How do I go about doing that? And that's where the term generators comes in. You'll either find the term generator or arbitrary being used a lot in these particular testing frameworks. So let's take a look at some custom generators. Some are pretty funky, some are pretty cool, but all in all, you should have the ability in property-based testing to create your own types. Okay, so let's take a look. So first one, let's take a look at, I'll just use jQuick first, and let's take a look at generators right in here. Okay, so, interesting, arbitrary. Okay? Very much like Scala. Scala does the same thing. Use gen and arbitrary to create your own types. But the way you do it is you usually base it off of something else, like strings, ints. Like you always come back to your basic types before you create them. Okay? So start off with that and then manipulate that afterwards. So if I wanted to say, in this case here, this arbitrary is kind of unique. Let's say I have a list of countries, okay, that I want to use. So I'm going to bring in this string in here, do a split, convert it into an array, and what I could do is just, purely just say arbitraries dot of country strings, and now the values that I'm going to be using are not just any regular string, but an actual country from our world. Okay, so that's our arbitrary. Again, let's take a look at arbitrary. You have a lot of choices in here. So you can give it a list of values. So it's just going to pluck something out of it. Genericize. So that's an arbitrary of t. So if you have a list of strings or numbers, whatever it is, it'll just pluck off of there. So arbitraries has a lot. You could get random values, one of. You get a constant value, default for type, lazy, recursive, any given number of samples, strings, big decimals, integers. And you can kind of see that you have a lot to work with here. And whatever kind of values you want to create, you could do so here through this arbitraries. Okay. Now that you have this arbitraries in here, you could plug this in to your particular property. So let me scroll all the way down here. Okay. So here's this country property in here. Now this countries right in here has to do with this provider name right up in here. At provide value countries. Notice the name that I have here. I labeled it countries because what's going to distinguish this from the rest of the string world, right? So I want this a little bit specific. So I'm going to use an at provide here. And then right down here, I'm going to say for all. Now what it's going to do, it's going to use the type system. It's going to say, oh, you need a string. It always uses a type system. You need a string here, but I have that @from, which states, go to the arbitrary or the provider that has that particular annotation, and let's bring in those particular countries. So that's the one I'm pointing up there. So that just shows, hey, here are the countries. Let me go ahead and run this particular test for you, and you get to see the countries as you define here for your generator, okay? So I'm creating country pairs, so Zambia, Dominica, Slovenia, Nicaragua, Cuba, Andorra, okay? So pretty awesome stuff. But take a look at this. These are pretty powerful in that I could use one arbitrary to plug it in into, say, like a collection. So this one says, do a for all, and what's the type now? A list of strings, so it's going to provide me a list of string, but choose the country names instead of it. So now what I'll have now is when I run this, I will have a country list of all the elements. So here we go. Okay, beautiful. There it is. Okay, different sizes. The empty is actually going to be in there, but you can build one on top of the other. So if I have an arbitrary for countries, I can make a list of it as well. Okay, so.
Does that for all make it generate all of them? So it's not like picking off a list like we were doing before.
Yeah, it's a random generation. So it's creating a list and just randomly picking out some of these string countries in there and then just delivering that for you.
Not all of them. Like it's
No, it's not all of them, yeah. Each round is going to be a little bit of something, because one of the rounds is going to be an empty list. Like it's not going to choose anything at all. Again, it's meant to surprise you. Okay? Oh. Yeah, so all of them have, like, it's called a verification mode. So you could say, these are the number of checks that I want to provide. I want to run this 10,000 times or 10 times or whatever amount you want. Yep, absolutely. Okay, so lots of generators. So here's a custom generator in the way that it looks for, this one's a JUnit quick check in here. Somewhat different. This one you have to extend a generator for whatever type that you're creating. And to do this, you would have to override the generate method. Here's a generate method in here. This provides an object for your randomization. So you could pluck from here and do something randomly with it. That's what this particular object is. This one allows you to steer the results. So your next result may do something slightly a little bit different. So if you want to anchor to that, you certainly can. But here's the same thing with the countries, okay? So here are all the countries. They're going to pick at random, and you can do whatever it is that you like. And so right in here, I'm going to use that source of randomness in here and use next int. So give me a random number. I'm just going to pluck one out of here and then provide that over to you. So a little bit more involved. Now, as far as generators, let me show you this one. This one's only unique to JUnit check. Here we go. Let's say I have a wrapper. Okay, adapter pattern, everyone knows this, everyone has this in their code base. So dollars, I want to create a custom dollars class that is wrapped around an integer. Okay, here it is. And I don't want to get too involved with this, so one of the things that JUnit quick check has is this notion of a CTOR, which I found out is what C# programmers use all the time. I'm like, I don't think Java programmers use CTOR, because I forgot what that was, or I didn't even know what it was to begin with. But anyway, what this one's going to do is that it's going to use the constructor that is inside of dollars, and then whatever the constructor is accepting, it's going to provide a random value in that. So the constructor for my dollars, let's take a look over here, right in here. There's dollars. Let's take a look here. My constructor accepts an int. So this property testing framework knows, hey, since this is accepting an int, I'll be happy to generate any random int, plug that into dollars, and then take that object and use that as the generator, okay? I think kind of clever, but it's a different way to generate stuff, okay? So Vavor, you already saw a little bit of that. So let's take a look over here as to what Vavor looks like. So here's a custom generator for Vavor, same thing with a country in here. Okay, so arbitrary of countries.split. Okay, but just to show here, That one's pretty easy. But just to show you can create lists of stuff as well. So if I want a list of countries, I could do arbitrary.list country arbitrary, and that would provide a certain list. So let me run this one. You get to see how that looks. So here are the list of countries in here. If I run this one, okay, different sized lists. Again, you never know what it's going to be. Somewhere in here, I think there ought to be like an empty list, I hope. Here's one with just one. So whatever kind of information you want to generate, that is available to you. So I have about 10 minutes left. Let me just skip some of the slides, but talk to you about a couple of major things. One of them is nulls. Now, nulls are a weird thing because in Java, we're learning to avoid them. How many of you use like optionals more and more now? Like you're just avoiding nulls at any kind of like, you never wanted that circumstance to come up ever again. So you're using optionals more and more, but nulls are a fact of life. And so inside of our testing frameworks, we would certainly have to account for it. So here's a null. So this one we're looking at jQuick over here. You could provide a null with an annotation in here. And what this would do is it would give a probability. So I have a 10% probability that that first integer on there is going to be a null. Now be careful with types because we have primitives. If you have a primitive and that null there, things are just going to start breaking here and there. So make sure that it has the possibility of actually being null, so that way you could plug in some null values to make sure that you accounted for that in your test. Okay? So you could put some percentages on both. So here's JUnit Quick Check, just to give you an idea of that. And here it is. So here's the null generator. You could use nullable, or their annotation is called null allowed, so you can provide your own probability. Now, do we have that in Vavor? Remember, no annotations in Vavor. That's not the way we like to roll. The way we like to roll is you program that yourself. So using these generators in here, you specify then, hey, I want any of these strings, but also include null in that pool that you choose from, okay? And so this one's just using a gen of null. Now, right over here, you could have frequencies. And this uses a tuple. So this one says, all right, so my setup now is generate a string 90% of the time. Now you see that there where those tuple 2s are in the middle of the screen? So 90% of the time generate a string for me, but 10% of the time generate a null, okay? So you could kind of guide it. It's still randomized, but you're guiding the kind of information that's being generated, okay? All right, now I only have about 7 minutes left. Let me tell you about another item, and that's called shrinking. Let's do this one over here. I think this one we're using jQuick. Let's see, I'm going to do a shrink on this one. And maybe I won't have time to show you all of these. JUnit and Quick have this notion of shrinking, and you can kind of see right here what a shrinking will do, okay? So the original sample that failed the test, so what it's going to do is it's going to go through all these values and then boom, fail it, okay? And the original sample that failed this particular test was this, -272, -4, blah, blah, blah. That was the original sample that failed your test. But what it's going to do is it's going to shrink it. That way you get a better grasp of it, a better understanding. So once we shrink this original sample, then we have this sample. Both of these will fail. It's just easier for me to comprehend this one right over here. Okay? And this says, hey, 0 and -1 is going to fail you just the same. You don't have to use this big old list over here. 0 and -1 want to do it. Now, what does this mean for us? Now, if you're a TDDer, I could then take that original sample, create a TDD test out of it, plug the hole, and then just run my property test over and over again. Better testing over time, okay? By then you should get like a sweet tear, just, that's so beautiful, man, because it's just gonna make your software even better, okay? So that's the notion of shrinking. And let me just end here with a verification. properties. Most of these will have ways that you can guide things. So one of them is this. This one says, hey, I just want to run this like 3 times, but I want to do an exhaustive mode in here. Let me run this one, this A and B in here. So what's an exhaustive mode? Let's say I want test elements for chess squares, right? A through H and 1 through 8 for playing chess or checkers, okay? And so in exhaustive mode, let's bring up the Cartesian product of it all. So 8, 8, and I would have like 64 discrete elements from it. That's what an exhaustive mode is. Let's take a look over here. So when I run this here, take a look here. I have 9 elements. Remember, I had 3 tries, but let's take a look here. This kind of looks like a nested for loop, right? The first round was 169, 146, negative 77. Then we see it again, 169, 146, negative 77, etc. Okay? That's an exhaustive mode. So you can mold things however you want. These are called a verification mode, and most of these will have that. Okay? All right. So we have about 4 minutes left. Any questions? Yeah.
On the C2 constructor like C2R,
Yeah, C2R.
does it knows that if there is a hierarchical class, does that as well? Like if the constructor has another class in it,
Yeah.
does it only work for the base classes, base primitive methods, or for the other classes as well?
For the other classes as well, as long as you abide by the rules for the constructors. They have another one called fields that you may also be interested in. And what that's going to do is that if you have some exposed fields, hey, still doing a presentation? We're hearing you too much? All right. So there's also fields to where you can go to fields and input the whatever values that you want. So you could either do constructor, but you just have to abide by the rules in order to do that. Okay? Any other questions? All right, cool. Well, thanks very much, everybody. Enjoy.